Hi everyone, this is our project, Flood Sensor 1, created by Delaney, Dominic, and Siraj. Our client is Chip Bobbert, the senior architect of the collab. He came to us with a problem. His kids play in the Eno River tributary that runs through his backyard. The river is prone to flash flooding, which poses a serious drowning hazard to his small kids. He would like us to make a device that addresses the current lack of flood sensing technology. This device will monitor the water depth and notify him to dangerous conditions. After extensive brainstorming, screening, and scoring, we selected a final design that measures water depth with an ultrasonic sensor stationed at the top of a 10-foot tall PVC pipe. The bottom of the pipe has holes cut out of it for water to flow through, thus pushing a buoy inside up the pipe. The pipe also has holes at the top to allow for air pressure relief. The ultrasonic sensor is then able to read the depth of the water by measuring how close the buoy is. This sensor communicates with an Arduino mounted on the top of the pipe in a 3D printed enclosure we call the birdhouse. The Arduino then communicates with an interface called Blink over a Wi-Fi network. The Blink interface sends push notifications to the user if flood conditions pass a dangerous threshold. The user can also view current and historical water depth data for 3 months in the Blink app. The whole device is powered by a solar panel stationed at the top of the birdhouse, and a battery backup is used for stormy conditions and nighttime. We wanted our device to be accurate, durable given the wet environment, able to store long-term data, easily assemblable, and have enough power for at least 3 months. We also knew we needed our project to alert the user to unsafe flood conditions, be rugged, and cost less than $100. We evaluated our project's effectiveness on all these objectives, setting up several tests. For demonstration purposes, we placed the device into a bucket and filled it with water to simulate rising depth. The buoy resting at the bottom floats to the top of the water in the pipe, which registers a closer distance reading on the ultrasonic sensor. This data is then reported over Wi-Fi to the Blink app, which shows the rising water depth. Implementing an ultrasonic sensor into our design allows us to measure the water's depth with very fine detail while keeping the design relatively simple. Our product's code utilizes 2 methods to determine whether flood conditions exist: rate of rise detection and a depth threshold. These 2 mechanisms allow us to rapidly detect changing water depth so that the user has enough time to clear the area. This functionality can be tested by inserting an obstruction through the air ventilation holes as shown. This will register as a sudden change in water depth above the threshold of 6 feet, sending a notification to the user. We do have some future plans, including solidifying a standard mechanism to mount the device and finding a way to network multiple flood sensors together. All in all, our product offers a powerful and cost-effective way for homeowners with flooding issues on their property to measure water depth over time and receive alerts when flooding is imminent. We would like to thank our professor, Kevin Caves, our technical mentor, Kip Coonley, our teaching assistant, Megan, our lab manager, Murad, and our client, Chip Bobbert, for all of the guidance they provided throughout the design process.